Hey YouTube, my name's Neil and I'm the head of maths at MyEdSpace. In this video today we're going to tackle the binomial expansion. Afterwards we'll be able to expand any bracket to any positive integer power. We're going to look at Pascal's triangle. If you learned something, feel free to subscribe and hit the like button. Share with any of your friends who you feel like it will benefit them also. If you want a free cheat sheet to this topic, then ping me on WhatsApp and feel free to follow me on Instagram as well. Details to all are down in the description. I hope you enjoy. So, to the maths. Yeah, I hope we're ready. We're ready for this maths, I hope. Yeah? So, starting off with Pascal's triangle. Hopefully, you guys have heard of Pascal. Maybe you've seen it before. What color do you guys like? I like blue. I like blue and red, but, you know, maybe drop in the comments. What color do you guys prefer? I'm going to start off with blue, and then maybe I'll see which color you guys prefer. But essentially what the binomial expansion is about expanding brackets. Yeah, and it's in year 12 anyway, we focus on expanding brackets to natural powers. Natural powers meaning positive whole numbers. In year 13, we look at expanding brackets to like fractional powers. So like, how do you expand a plus b to the power of a half? Or negative powers, so how do you expand it to the power of -2? Super cool. White, yeah. I'll be writing in white, that'll be great. So here we're going to be focusing on natural numbers. So if we expand anything to the power of 0, I'm sure you guys know that means that you are left with 1. Anything to the power of 0 is 1. Now I'm going to place things tactically, so I'm going to put the number 1 here. Yeah. A plus b to the power of 1, we know a plus b, well, anything to the power of 1 just leaves you with the same thing, right? So I'm going to write a plus b, but more specifically, I'm going to write 1a plus 1b. Yeah, it's the same thing, power 1. When we square it, you know, I'm not going to write the two brackets, but if you were to write the two brackets, you would get 1a squared plus 2ab plus 1b squared at the end. Now, as you get good at binomial expansion, you're going to be able to do what I'm going to do now. So, if you were to write out 3 brackets and expand a plus b cubed, what you would get, and you'll see why I can say this without doing 3 brackets, you'll get 1a cubed plus 3a squared b plus 3ab squared plus 1b cubed. Yeah? Now, power 4. What do we do when it's power 4? Well, we have 1a to the power 4 plus 4a. You might be thinking, how am I doing this without any aid? But I don't need the aid. So it's 4a cubed b plus 6a squared. I need to make sure I don't write over myself here. 6a squared b squared plus 4a b cubed plus finally 1b to the power 4. I'm moving out of the way just so you can see. Can you not see that? I need to make sure I move my head the right way here. Yeah? Okay. Ideally, I wanted that 1b4 to be slightly this way so you could see the triangle. But what I'm getting at here is this is what Pascal's triangle is. I'm going to highlight the numbers. So you have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. It's supposed to look like a triangle. It looks like a triangle, right? Ignore this last one, but I've kind of structured this so that you can see the triangle, right? So this is Pascal's triangle. It's really cool. So where's my pen gone? There it is. So we have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. Now, the way Pascal's triangle works is you take the top 2 numbers and you add them to make the bottom number. So 1, 2, 3, 1, 2, 3, 1, 3, 4, 3 plus 3 is 6, 3 plus 1 is 4. And What this means is, well, really, I'm going to show you a shortcut to this, but this is Pascal's triangle, meaning if I was to expand to the power of 5, then I would know straight away that my coefficients become 1, 5, well, we've got 10, 10, 5, 1. Now, what you might notice is that for the first term, the power goes down, 4, 3, 2, 1, and then it disappears. Water, it would be easier to use a calculator, which I'm going to show you in a second, because right now what I'm doing is I'm showing you the basics, where everything's coming from, and then I'm going to show you how it links to how we can use the calculator, because really, you know, if I ask you to expand power 10, then we're not going to do Pascal's triangle to the 10th row, right? But we want to see where everything comes from, ideally, right? So alternatively as well, the B, can you see there's none, but then it goes up in power. So as one goes up in power, the other goes down in power. And that's Pascal's triangle. So again, if I wanted to expand something to the power of 4, then if we were to refer to Pascal's triangle, we would have 1, 4, 6, 4, 1. And all you would do is write this down. 1, 4, 6, 4, and 1. And like I said, one term goes down in power, so the x, you would have power 4. Then it goes down in power. Then you have 1, and then none. Then the other one goes up in power, but remember it starts off from power 0, right? So 2y to the power of 0, 2y to the power of 1, 2y to the power of 2, 2y to the power of 3, and then 2y to the power of 4. Don't forget the pluses. And really, your calculator will sort you out here. I do have my calculator, yeah, but I'm not going to use it. Let's see how good my arithmetic is. But anything to the power of 0 is just 1, so we don't need to worry about that. So we have x to the power of 4 plus. Here we have 2y to the power of 1. Anything to the power of 1 is just itself. So you're just left with 2 times by 4 gives you 8. You have x cubed. Then you have y to the power of 1, which is just y. Now here, don't forget your bid mass. I don't think anyone said, no one says bod mass anyway, yeah? So it's bid mass. 2 squared. 2 squared, we're going to do that bit first. That's 4. Then we times that by 6. Hopefully you're following. That's 24. Yeah, so 4 times 6. Is there a difference between a plus b in the back? Okay, so Jonathan, good question. Let me answer that at the end of this question, but I'll show you something very simple. We'll answer a question where there's a minus. But yeah, there is a difference, but something very small. Good question. So 2 squared 4 times 6, 24. Don't forget we have the x squared. Then we have y squared. Ped mass, we use parentheses. That's very American. The next one, 2 cubed is 8. 8 times 4 is 32. Then we have x to the power of 1, which is just x. Then we have y cubed. Plus, last one, x to the power of 0, remember that's just 1. 2 to the power of 4, 16. Y to the power of 4. Yeah? Look at that. We expanded to the power of 4 super easy, super quick. Yeah? As Esther said, that is legit so cool. That's legit so cool. 1 second, don't know. What did you say? 1 times 1 is 2. I don't know, man. That might be some branch of maths that I'm not quite aware of. But Jonathan, your question was, what would you do if there was a minus here? Now, all that would happen is, say it said x minus 2y. In all of these brackets, instead of writing 2y, we would write minus 2y. That's all. So you just have, there's just another layer to it in terms of, if I was to do minus 2y squared, instead of thinking about 2 squared, I'd be thinking, oh, what's minus 2 squared? If it was 2y, the minus 2y cubed, instead of thinking of it as 2 cubed, I'm thinking about minus 2 cubed. Yeah, so that's just the difference. So next one, we're doing power 3. If I was to refer back to Pascal's triangle, power 3 is 1, 3, 3, 1. We just write that down, just so I don't write over everything else. 1, 3, 3, 1. Remember, one's going to go up in power, one's going to go down in power. So we can go down in power by x, x cubed, the first one, x squared, x, then nothing. Then the other one is going to go up in power, yeah? So 1 over x to the power of 0, 1 over x to the power of 1, 1 over x, power of 2, 1 over x to the power of 3. Now, in general, you want to leave enough space. Yeah, Leona, you always, so in A levels, every single exam is calculator. Yeah, it's not like GCSE where you have one non-calc and 2 calc. Here, you're gonna have a calculator for every single exam. Yeah, which is good and bad. You know, sometimes we like to test our arithmetic, but yeah, every single paper is a calculator. Now, doesn't matter what you do, it's always a plus in between terms. If there's ever a negative, like we were discussing with Jonathan, that's addressed inside the bracket. Now, here we got to be careful with our simplifying. So again, 1 over x to the power of 0 doesn't do anything, that's just 1. So we have x cubed plus. Now here you need to, observe, maybe we can do this in 2 stages. So we have 3, then we have x squared, and then we have times 1 over x. Now we should know that when we multiply, the x's will cancel, right? X squared just means x times x. If we divide by x, they cancel. So we're just left with 3x plus 3x. Then 1 over x all squared becomes, you square the top and the bottom. Yeah, so 1 over x squared. Lola, what I can do is at the end, I'll write down in the comments which calculator is the official one for the A-level exam. So yeah, I'll type that at the end for you. Yeah, just make sure you stay till the end and write the question again for me. Yeah, so good. Thanks for the question. So here we have x and x squared in the bottom. So again, the x here will cancel the squared in the bottom, so it becomes 1 over x. Yeah. And then finally, just making sure I don't write over myself. We have 1, which doesn't do anything. We have 1 over x cubed. You cube the top. 1 cubed is just 1. X cubed is just x cubed. And now we can write our final answer. So we have x cubed plus 3x. Don't forget the x is cancelled, so we have 3x. Now remember, this is now 1 over x. When you times it by 3, we multiply the numerators, so it'll be 3 over x plus 1 over x cubed. And there you go, there's our final answer. Now another thing is, at A levels, they don't give you an answer box, so you must make sure you underline your answers now. Yeah. How has this even got anything to do with the binomial expansion? Yeah. Well, interestingly enough, we said that we don't want to write Pascal's triangle every single time, right? So Pascal's triangle, Pascal's triangle actually is equivalent to the n choosers. Yeah, so say you were interested in the 4th row and you couldn't be bothered to write Pascal's triangle, all you do, 4 choose 0, 4 choose 1, 4 choose 2, yeah, like we did here, and it tells you the line. So say you wanted the 10th line, we're not going to do Pascal's triangle, we're just going to do 10 choose 0, 10 choose 1, 10 choose 2, we're just going to keep going. Super cool, super interesting. Say we changed 3 red into, 1 second, Peg, I'm just getting the chart. Say we changed the 3 red into 3 unique objects. Would you divide by 4 factorial? Okay, so if you had, so say that, well, it would be different in that case because you would divide by 4 factorial in terms of the blues, but then the others wouldn't actually make a difference since they're unique. So you would only have to divide, just like you said. Well done, that's a great question. You would have to only divide by 4 factorial because the blues are the only ones that are unique there. The other 3 objects, because say it was red, yellow, black, you wouldn't have to divide by anything with those because they're unique. But the only thing is that we wouldn't use that with the binomial expansion just because we're dealing with 2 objects. Like I said, if you wanted the 10th row of Pascal's triangle, you're not going to go all the way down to the 10th row. You're going to say 10 choose 0, 10 choose 1, 10 choose 2, etc. Yeah? So, power 8. Power 8 means we want the 8th row of Pascal's triangle. 8th row means we want 8 choose 0, 8 choose 1, 8 choose 2, 8 choose 3. Can you see they only want the first 4, like I said? So we're not going to go all the way up to 8 choose 8. Now hopefully you lot have your calculators with you, so we can type this. But maybe you recognize with Pascal's triangle, can you see all the columns, sorry, the first numbers in the columns are 1, right? So we have 1. I definitely know that this is 1. Then the second number is always what the power is. So in this case, 8 choose 1 is going to be 8. But you can verify this with the calculator with me. Now 8 choose 2, I'm going to type that in. 8, then we do shift, press the divide button. 2, you see that's 28. Yeah, 28. And then, where's my thing gone? Yeah, 28. Then 8 choose 3, we can just go back, change that to a 3. Small hands, 56. Okay, we got the coefficients. Now we can do what we were doing the whole time, right? So we're going to have 1. The first number there is 2 to the power of 8. That's going to go down in power, then the other one's going to grow. We're going to have t cubed to the power of 0. Then we have 8. Then we have 2. It's going to go down in power, 7. T cubed. This is going to go up in power now, 1. 28. 2 to the power of 6. T cubed. Squared. Also notice that the powers add up to 8. 8 plus 0 is 8. 7 plus 1 is 8. 6 plus 2 is 8. Yeah? Plus 56. 2 to the power of 5. T cubed power 3. And from here, we can just simplify. You could write as well plus dot 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 because it does keep going, right? All right, so we have 1 times 2 to the power of 8. So 2 to the power of 8 is 256. 256. Now we have to do 8 times 2 to the power of 7. 8 times 2 to the power of 7. 1024. 1024. Now we have t cubed to the power of 1, so you just get t cubed. Now we're doing 28 times 2 to the power of 6. 28 times 2 to the power of 6. 1792. Now t cubed all squared. Hopefully we know that in this situation we don't add powers, right? We multiply them here. So we t to the power of 6. Then we have 56 times 2 to the power of 5. So another 1792. And again, we multiply the powers, t to the power of 9. We can say plus dot dot dot. There you go. The term independent of x in the expansion, x cubed plus a over x squared to the power of 5 is minus 80. Find the value of a. Now, we all know, hopefully, what independent means of x. Independent of x means that there's no x term. Now, as you get good at this, you won't actually have to do the full expansion. Yeah, you will only need to expand up until a certain point where you spot the pattern. But say we want to do the full expansion and we wanted to find through the cancellations which one was the term independent of x, then don't risk it in the chat. I mean, don't risk it. Don't risk it in an exam. Just write every term. Yeah, we're not here trying to lose marks. We wanna get full marks in our papers. Yeah. So is power 5. We're talking about the 5th row of Pascal's triangle. Now, if you were to type this in your calculator, you'd have 5 choose 0, 5 choose 1, 5 choose 2. I think we all got the hang of that. But what that would give you is 1. It'd give you 1, 5, 10, 10, 5, 1. Yeah? 5 choose 0, 5 choose 1, 5 choose 2, 5 choose 3, 5 choose 4, 5 choose 5. Yeah? Then we've got to do the expansion. So we're going to have 1. Remember, 1's going to go up, x cubed to the power of 5. Yeah, then it's going to go down. Then we'll have a over x squared to the power of 0. 5. X cubed to the power of 4. A over x squared to the power of 1. Hey, yo, guys, I swear we've got the hang of this now. We know what we're doing. You lot could answer this yourself. Then that's gone down in power, 3. The other one's going up, so it'll be squared. A over x squared squared. Hopefully I can fit this on one line, but I don't want to cramp it in. X cubed squared, a over x squared cubed. We have 5 x cubed to the power of 1, a over x squared to the power of 4. Okay, I'll run out of space here, but 1. Then we've got x cubed to the power of 0, a over x squared to the power of 5. There we go. So, what you want to do from here, yeah, remember this is, we would practice a lot more of these questions, is we want to observe that line and we want to see which one of those terms would the x's cancel out completely, yeah? And I'm going to show you visually how I would do it in my head, but I'm not going to write it down. So it's important you listen to what I'm thinking, yeah? So the first term, look here, it says x cubed to the power of 5. Remember, you multiply, it's x to the power of 15. Down here, you have x squared to the power of 0 in the denominator. Well, that just gives you 1. So this first term, x to the power of 15, and this x term in the bottom would not cancel. So this, no use to us. Next one, can you see it's x cubed to the power of 4. What do we do here? We multiply the powers, x to the power of 12, right? In the bottom, you have x squared to the power of 1. Forget about the a for a second, I'm only interested in the x's. So in the denominator, I have x squared to the power of 1, which is just x squared. Would x to the power of 12 cancel x squared? The answer is no, right? Next one, we have x to the power of 9. 3 times 3 is 9. So x to the power of 9 on the top. Then in the denominator, x squared squared. That would be x to the power of 4. Yeah? Would x squared and x to the power of 4 cancel? No, it wouldn't. Okay, ignore it. Next one, look. X cubed all squared. What do we do here? We multiply the powers. X to the power of 3 squared, that's x to the power of 6. In the bottom, you have x squared cubed. That gives you x to the power of 6. Here now, we have the cancellations. This is where things start to cancel. So, if I write this out properly, I don't still want to be on the highlighter though. I have this, I have 10. X cubed squared, that's x to the power of 6, isn't it? A over x squared cubed, the top we square, cube, sorry, will be a cubed. And on the bottom, x squared all cubed is x to the power of 6. Look, there you go. This is the confirmation. They cancel. Good stuff. That simplifies to 10a cubed. So it's 10a cubed. Now, what did we say? We said the term independent of x in this expansion is minus 80. We're saying this value here is minus 80. Now, we all know how to rearrange, I hope. Yeah? We're going to divide by 10 on both sides. A cubed equals minus a divided by 10 is minus 8. And then we cube root both sides. The cube root of minus 8, we don't need a calculator for this, right? So we cube root that, we get minus 2. Nice. Given that, k minus x to the power of 9 is equivalent to a minus bx plus bx squared. Find the values of the positive integers a, b, and k. Now this question here was so badly answered. So I was an EdXL examiner, and when I was marking this, it was so badly done. But it's actually reasonably simple. So this is for those that were asking about if you had a minus b in the bracket, what do you do? 9 choose 1, 9 choose 2. Now you should notice that we're only looking at the first 3 terms, right? So I'm only looking at the first 3 numbers of Pascal's triangle. Now, if you remember the first number in Pascal's triangle is 1, isn't it? 1. The second number is always the power that you're on about, so it'll be 9. Now, you should all have your calculators on you. 9 choose 2, 36. 36, okay, sure, there you go. Okay, now we're expanding k minus x to the power of 9. So, we are going to have 1. K to the power of 9 minus x to the power of 0. Then we're going to have 9 k to the power of 8. So now I'm going down in power with the k's and I'm going to go up in powers with the minus x. So you can see I'm including the minus here. Yeah, it's k minus x. The sign is attached to the x. Yeah. So minus x to the power of 0, minus x to the power of 1. Then 36, going down in power, k to the power of 7 minus x squared. Can you see they have a squared term here? We're only going up to the squared term here. Yeah. Right. 1 doesn't do anything. Minus x to the power of 0 doesn't do anything. We have k to the power of 9 plus. Now be very careful here. Always deal with the x bracket first. Can you see it says minus x to the power of 1? That's actually a negative. Minus x to the power of 1 is minus x. Yeah, if I just write underneath, that says minus x. We times that by 9, that's minus 9x. So in fact, I wrote plus, it's actually minus. Minus 9 k to the power of 8 x. Yeah? Next one, minus x squared. Anything squared, the minus doesn't, nothing happens, right? So minus squared just becomes positive. X squared is just x squared. So we have x squared there. We have 36 though, so it's positive. 36 k to the power of 7 x squared. So we're saying this thing here is equivalent to a minus b x plus bx squared. Now this, what we're going to do next is something known as comparing coefficients. Meaning, the coefficient of x squared has to be the same on each side, yeah? Because we said we use the good Mohammed, so same as, so equivalent is the mathematical term we would use more specifically. But yeah, the coefficient of x squared here on the left side, or the right side even, is b. But what is on the left side? It's this, 36k squared. Because we're using an equivalence here, b must equal 36k to the power of 7. Also, if we look at the coefficient of x, make sure you include the minus. The coefficient of x here is minus b. The coefficient of x here is minus 9k to the power of 8. They must be the same. And finally, let's get a good color here. A. This is just the constant. This is the term independent of x. Yeah. On the other side, that's k to the power of 9. That's enough for us to find out what a, b, and k have to be. So remember what we said? We said b, if we look at the yellow highlights, b equals 36k to the power of 7. Also, minus b, if we look at the coefficients of x, the green, minus b is minus 9k to the power of 8. Now hopefully you should be tempted to do something here, times both sides by minus 1. We get b equals 9k to the power of 8. We can actually form a connection here, right? b equals 36k to the power of 7, and b equals 9k to the power of 8. But let's just finish off by saying the orange highlight. So a equals k to the power of 9. But now let's deal with this. They both equal b. So we can say now 36k to the power of 7 equals 9k to the power of 8. Now we can start dividing both sides by numbers and by letters. We can divide both sides by 9. Divide both sides by 9. 36 divided by 9 is 4. K to the power of 7 equals k to the power of 8. Now you should hopefully see that we want to divide by k on both sides. But if we just divide both sides by k, then the k to the 7 will become k to the 6, and the k to the 8 will become k to the 7. But we can then just divide by larger powers of k. Think about it. What's the largest power of k that we can divide by? Well, we can go all the way up to k to the power of 7. Divide both sides by k to the power of 7. The k to the power of 7 here would cancel. We're left with 4. K to the power of 8 divided by k to the power of 7. We take away the powers. We're left with k. And now that we have the k value, everything else sorts itself out. Remember what we said? We said b, if we come here, b, oh, I've got a big graphics board here. It takes a bit of time to go down. B is, I'm just using my calculator for this. B is 36. K is 4. Make sure you use a bracket here. Power 7. Yeah? Yeah, 36, 4 to the power of 7. What's up, Omid? We got, oh, it's a big number, 589, 824. Nice one, Farhan. Oh, 924, not 7. It's a big number. And then finally, A is k to the power of 9. Remember, k is 4. Power 9. 262, 144. There you go, there's the answer to that. Right guys, I hope you learned something new today and you enjoyed the video. If you did, feel free again to subscribe and like the video. Share it with your friends if you feel like it will benefit them as well. And as I said, if you do want a free cheat sheet to this topic, then make sure you ping me on WhatsApp and feel free to follow me on Instagram as well. All the details are in the description below, and I look forward to seeing you in my next video. Peace.